Hi Vijay,
Hello.
can you tell us a few words about yourself and about the tool you want to show us?
Yeah, of course. So my name is Vijay. I work as a leading. I basically lead the open source developer tools at a company called Soda. I've been working in software for I think around 18, 19 years now, building different types of pieces of software, all the way from desktop apps to enterprise applications. In the recent history, I've been working with data related stuff a lot. So mostly data analytics, data science, data engineering, leading the teams. And at Soda, we started building this data quality and data reliability tool. So that's what I would like to present today.
Quite interesting.
Okay, so as I said, I work for the company called Soda. This is a brief, I don't want to bore you with slides because this is supposed to be like a showcase. So we'll jump into the demo as quickly as possible. Just to give you some background on what we do and why are we doing this. So what is Soda? So Soda is a company that we're working on helping other companies resolve their data issues so they can find, analyze, and resolve data issues before the people who are using your data for decision making are affected. So that's our mission and vision. How are we different from other in this domain? So we have prescriptive workflows. That means you can involve entire data management team because some of the tools that are in the domain right now, they are focused on engineers mostly or focused on analytics mostly, analysts mostly. So we were trying to bring in everybody together, which leads us into analyst self-serve. So we want both engineers and analysts to use a tool together. So the tool is easy enough for analysts to get started and also powerful enough for the engineers to reap the value, reap the benefits of the tooling. And so that's our another USP, I would say. And then finally, everything is built for data engineers. That means Soda Core that I'm going to present in a bit. It's completely open source, and we don't have any limitation around the open source tooling that we are providing to the community. So everything is built on top of this core, whatever the commercial offering that we're building. So what are we going to show today? I'd like to show a new a tool that we are building and also a new language that we are building that is called SodaCL, which is Soda checks language. And the tool that is going to evaluate everything that is written in SodaCL is called Soda Core. So what is SodaCL? SodaCL is a DSL for data reliability, DSL being the domain-specific language. It's open source and free, free as in beer, as they say. So it's Apache license, so it's written in Python. And it's both a library and a CLI tool. So that means you can also embed it into your Python programs, as well as you can just use it as a standalone tool. So being a library, that means you can also introduce into your orchestration pipelines fairly easily. And it's extremely easy to use it in your own projects, which I'll walk through quickly. So the question is why we should, why did we start on this journey? The main reason is that SodaCL is a new language which is based on top of which is built on top of YAML. If you know, we released SodaSQL a few years ago, and that has got a significant amount of traction, and we got a significant amount of feedback from the community. And based on that, we went back to the proverbial whiteboard, and then we started designing a better looking language. So the idea here is that the data reliability is that the SodaCL is targeted towards all the three personas that we have usually in the data teams, which are data engineers, data analysts, as well as data owners. And so why? Because as I said, it's extremely easy for engineers to get started with SodaCL, which I'll give a demo quickly. And then also this enables, having a nice DSL enables people who are not that familiar with programming or the engineering and everything to get the value out of it as well. So we are targeting both engineers and self-serve for the analysts. And so I would like to directly jump into the demo first because I don't want to, as I said, don't want to bore you with too many slides.
Let's do
So
it.
yeah. What I have here is a
Very
fairly,
tiny, I can barely see it. Maybe you
oh,
can share only a part of your screen?
yes, I will do that. Or maybe I can just change the display size quickly. Let
Yeah,
me make it, it's going to be huge for me. Sorry for that. Is it better? What I have here is a small database with several tables. This is one of the tables. This is probably less important because we're not gonna, go through all the database schema and everything in this short thing. But I'd rather show you how SodaCore works. So how do you get started with Soda checks language? So we have this core tool called SodaCore. So essentially, you install SodaCore using pip install SodaCore dash. Currently, we have support for Postgres and Snowflake and BigQuery and Redshift. Other things are coming, so you can just type Postgres, and then you can see the whole thing is going to install the package. But I already installed it, so I'm not gonna do that again. I'm just going to switch to the virtual environment that I created already with the tool installed for the sake of time. So let me activate SodaCore. So here you can see the Soda command is already installed. And then here we are at the 3.0.beta 5, which is the latest one since yesterday. So everything is, I'll send you the links for the documentation, how to install it and everything, because we have, for the interest of time, I'm going to keep it smaller, not to let the pip do all the installation and compilation here. So the simplest thing to get started is to install whatever the data warehouse that you're using and the package for it. So in this case, I installed Postgres package, SodaCore Postgres. And I have a Postgres database running at with something called AdventureWorks, which is fairly famous example in the analytics domain and the database domain. So to connect with a database, what we need to do is to create a configuration file, which is similar to this one on the left-hand side. So here in the current directory, I have a checks YAML, which is basically empty for now, as you can see. And then I have the configuration file. So the configuration YAML is where you specify the data source related information. So fairly standard stuff here. You can see the type is Postgres, database, schema, and connection details. Now, once we have this one, then you can get started with writing your first so-called checks. So to write the checks, you do, let's say I have a table called dim account or customer, for example, and then I have something called row count. This is very simple check that you do at the table level test that you want to do. You want to make sure that row count is greater than 0. So that's the simplest possible. So quote unquote hello world for SodaCore. Now you can run this by essentially running SodaScan, and SodaScan has plenty of help here. So I'm not going to read through all that stuff. So you can do SodaScan and then specify wherever the configuration file is. We made it easy to load the configuration file if you have a .soda in your home directory, and then we'll read the configuration from there. So you don't need to specify this one here. And then I'm looking at what is the data source name. Here you can see the AdventureWorks as the data source. So that is the data source. I'll come to you why we have to specify that one. And then how many number of checks files. So here you can specify multiple checks files. So if you have one checks file for department, for example, all the marketing related data is being quality checked in one file, and then finances in a different one, you can do that. So here I can do checks.yaml. This is single line. So this is how it's going to look like. Now, when you run this, you can see SodaCore says one check passed and everything. I'd like to show you how it looks like when it fails. So let's say I expect the row count to be 0. Then you run it, and then it says, no, it's failed because I have around 18,000 rows in it. So that's how it will look like. So I'm gonna make it simple. So that is the first step to get started with Soda checks. Now we have several types of checks available in Soda checks out of the box. all the way from simplest things, like if you want to do something like an invalid values, invalid count. So you can do invalid underscore count for a given column. So I know that in the customer table that I briefly showed, I know that there is a column called English occupation. I want the invalid values to be 0. Now, what is an invalid value? Invalid value by default would mean anything null or an empty string. But you can also enhance it by adding the valid values. So you're basically providing the list of valid values for a given column. So I know that there is a, for example, professional, and then I have, look up the values management. So there are some other things here as well. So now if I run this one, and you can see there is invalid English occupation. It has failed because I expected everything to be valid. That means there are more values, not just these two. So there is even third value or fourth value, whatever. So you can also see there is a verbose option. If you pass that one, then it will print all the queries that we are executing. So you can use -V, -V to see the complete detail of what kind of queries that we're firing. And so this is how you can identify the categorical values that you want to test. And then you can also do something like, for the sake of the demo, I'm going to clean this one up so we see only one check per time, but then I'll run the whole thing later. So imagine that you want to check for you're ingesting emails, and then you want to make sure that there are no duplicates in the email addresses. So you can do something like duplicate count equals 0. And here, then you can see that it's pretty easy to run that one. Should have removed the. As you can see here,
work, this duplicate counts. Is it like it looks at the row, right? At the, like a row level duplicate.
Yes, exactly. So it's going to check. Yeah, this basically is the query. Yes. So for now, we're checking for email address, and as you can see here, it will also try to print if the email addresses are not unique or there are any duplicates. If there is an email that is repeated 2 or 3 times, then it will also print the value there, so you can see the value. And then, so for now, I'm going to remove the verbose thing, and still you can see it's going to print a summary of this one. I can try to change the email address quickly and then see if
basically let me try to make sure I understood what happens there. So it says that the number of rows with a duplicate is 0. So let's say if we have 2 duplicates, then like 1,
exactly.
or let's say we have 3 rows with the same email, that would be 1 duplicate, right?
Yes, exactly.
To the query, I see.
Yes. So I just changed the duplicate, so you can see. I mean, I just copy pasted one of the things. Now you can see this particular value is repeated 2 times, but the check value is still 1. That means there is 1 element duplicated once, but it appeared in 2 times in the code. So that's this is another check that is out of the box. We have plenty of things like this in SodaCL that you can use to. There are missing values, there are duplicate values, there are count-related values, and everything is documented right now so that you can use for these ones. You can also use minimum and a maximum for a given column. Now, another interesting thing that we usually do is the referential integrity check, because you want to make sure that some values in one table are the same as the values in the other table. So for that, so in this table, in this schema, which follows the dimensional model, I have facts tables and dimension tables. And I have a table called fact internet sales. And for this one, I can say values in a particular column here, which is going to be customer key must be or must exist in the other dimension. So we tried different syntactical things here. So here you can see this is how the reference check looks like. It's a one-liner just to show you how it's going to look like. And now this is going to check the referential integrity between customer key in the table fact internet sales versus the customer key in the dimension. So here, then you can see it's also trying to print all the rows because everything is there. So it's not going to give you the any results here. But if there is anything that is only available in the fact internet sales, but not available in the customer key, then it will print the failed row in this case, which shouldn't be there. Yeah, this looks a bit odd because of the screen size. And so this is one way of the thing. And then another one is you can also, if you're only interested in, imagine that you are ingesting data from a source database to a target database, then you might be interested in, make sure that just the row count is the same. So you can say row count same as some other table here, which is going to be fact underscore internet sales reason. So this is going to check whether row count in A is equivalent to row count in B. So here, as you can see, it failed. I mean, this is a contrived example, obviously. So it basically says, left value is 60,000 and the right value is 64,000. So the row count is not the same. So it will fail. Now, one of the interesting parts here is that, as you can see, there are different outcomes. This is what we call a check outcome. So the check can fail, check can pass, 0 pass, 0 failures. And we also have warnings and we have errors. So we can specify if something, for example, if this row count is not actually a critical error, then you can mark it as just as a warning. So you can say warn when something is happening. So, so referential integrity checks and individual column checks. There are also category checks, missing values, invalid values, percentages. Everything is available out of the box in SodaCore, in SodaCL. And we also have schema checks. So you can check if you're ingesting the data. And usually what happens is sometimes you're ingesting it from a CSV file or ingesting it from some JSON or something where the source schema might change and you're dependent on some particular columns to be available, then you can do something called the schema checks. And here I'll show an example of when we want something to fail. So here you want it to fail when required column is missing. So if one of these columns are not available in this particular, let me try to fix the indentation quickly. Yeah, so if any of these required columns are missing, then the check should fail. So if I run this one, then you would see everything has passed. And imagine that we expect data talks is awesome Boolean column, for example. I mean, I know it's going to be true, but for the sake of argument. So here you can see there is one failure because one of the column name is missing. So this is the column name that I expected in the table, but it basically failed. So this is how you can, as I said, you can also just change this to warning. Then it will be reported as a warning. The advantage here is that when you're doing it programmatically, when you're doing it using Python API, for example, or even the command line thing, then you can take a decision based on how many warnings are there and who to notify, and then how many errors are there and then who to notify. So if there is a big error that you want the engineering team to be alerted or the data ops team to be alerted, then you can just tweak it to say, oh, this is a critical issue, not just a warning. So this is one of the examples, and the schema checks are even more expansive than this because we also have a way to check the column types. So how does it look like? Let's say, I can say a warning when wrong column type, and each type of the column, you can specify customer key must be an integer, product key must be an integer, and sales order number, blah, 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 should be this and this and this. So you can ask the schema validation to make sure that, sorry, I think I need to, this is the indentation issue. Yeah. Okay.
What's the use case for this? So I'm wondering, so for a database, you have to specify the schema. Is this for dependencies you do not control? Is it for databases, for tables that are managed, let's say, by a different team, a different
Exactly.
department, right?
Exactly. Yeah. Because this has happened a few times when I was working with ingesting some other folks' databases. Then they decide, initially they start with, I don't know, some varchar, and then they realize, oh, this should be a UID or this should be a money column, for example, in Postgres. So they decide to swap the type of the column. Then usually it's not a problem because you ingest it as is. And then if you are doing non-incremental kind of ingestion, it's not a big problem. But sometimes you try to do the incremental ingestion via change capture, then the entire table changes, and then you need to get alerted. Oh, I expected the product key to be integer, but then suddenly it's a varchar now. So you can catch it at the ingestion point while writing the checks there. So there are several other ways of schema checks. Also, when you connect it to Soda Cloud, you can also do schema evolution changes. So previously it was this, and then currently it should be this. That kind of checks as well, but that requires a Soda Cloud integration. And then finally, we also have something called Freshness. So Freshness would mean how fresh is the data. So here we are checking for a given table, which is called facts of a response, and for a given column, which is called date. And date should be when it is greater than 1 day, whatever the value that we find in that one, then alert me. If it is more than 3 days, that means it has not been updated for over 3 days. So it can fail. So it can give you some, we have been running this for 4 days and then new data hasn't arrived yet. So this is another, I think, critical use case that usually we would like to help the data engineers to monitor the data freshness. And then finally, as you can see, there might be same checks that need to be applied for, let's say, 200 tables that you have in the data warehouse. Then it becomes pretty tedious if you start typing dimension account, and then you're doing, I don't know, row count again, row count greater than 0. And then I have the same thing being done for pretty much every other dimension table, just as for the sake of an argument, customer, and then, I don't know, dimension, invoice, or whatever. Then you're essentially, duplicating it, copy pasting all this stuff, which is irritating. So if you have a bunch of checks that you want to do on a large amount of tables, then we have this for each structure. This one will essentially run whatever the checks that you specify on this particular table pattern. So it also takes the pattern. So here, I think we have, let me try to run this. So we'll see how it will look like. Okay, file is saved. Now here you can see it has run the row count checks on 16 tables in one go. So that is the, also you can add other types of checks if they have to follow similar kind of pattern. And we're working on enhancing this to have much more conditionals here. So if the table name is this, then only do the row check if the table name is, so you can add much more enhanced way of writing the checks. So that's the brief overview of Soda Core. Just to give you how it all fits together, I'd like to briefly go back to the presentation. Yeah, so with that's all about the Soda Core that you've seen, and you can check the Soda Cloud for the commercial offering, so we can visualize all these results in the UI. You can get notifications and agreement workflows, and we would love if you give this a try, install it. If you go to cloud.soda.io, you can see all the details, and our project is at GitHub. So you can check github.com/sodadata/sodacore. And we also have a community Slack. You can join and ask questions on the Soda Core team and give us your feedback. This is still in beta, so we would love to have all your feedback on this and then shape the product.
Okay, thanks. I will put all the links in the description. So awesome. I have a few questions. I don't know how many we can cover, but maybe you can tell us how people can contribute to it?
Oh yeah, so it's currently there are first of all we love if people try it and then pick all the bugs that you find in the checks and these things. So please give it a try. And if you want to contribute, there are several issues on GitHub, and we are about to mark some of them as a good first issue, for example. So you can pick them. And also, we'd love to have any specific data warehouse that you're using that we are not covering, for example. Because right now, as I said, we only support Snowflake, Postgres, Redshift, and BigQuery. We have some Spark and Hive in the experimental stage that we'll release soon. If you're using Presto or Trino or any other data warehouse, we'd love to get the contributions on that one.
So we personally use Presto and Athena. So
yeah, exactly. Athena, Presto, and that'd be lovely to see contributions from that one. It's fairly easy. The API is easy to implement. So
yeah, great. Do you have any advice for anyone who is watching this?
Yeah, I mean, check your data. that's the biggest advice that I have. As I said before joining Soda, I was managing different data teams. One of the biggest challenges is making sure that we know as the data team, data engineering team, and the DevOps team about the issues that are going to pop up in the analytics dashboard before the analysts or people who are consuming the dashboard, and they call us like, this looks suspicious, which is not really specific, but that takes a lot of time to debug. And so I would recommend preparing your data pipeline in such a way that you can catch the errors as early as possible, so you don't surprise the people who are actually utilizing the data. So that's the biggest thing that we miss in the data domain, I would say, compared to the software domain. Yeah.
That's great advice. Thanks a lot. Thanks again for doing the demo. I'm sure many people will find it useful. And one thing from me, go to Soda GitHub repo and give them a star. They really deserve it. Great product. Thanks for putting a lot of work to Soda.
Yeah, and thanks Alexei for running this, and also the awesome community that you're running. And so we love to be part of this one.